So, as you can see, where we are from the last video is we have a pulse width modulation duty cycle updating based on an analog sensor reading. So, what we'd like to do now is start reading the ADC every 10 milliseconds and averaging this over the period of a minute. So let's have a look at how we can do this. So we've had the pwm.c file open, kind of referencing it as a driver. And so I'm going to take a millisecond timer function and use that. And we can see that this is timer counter 0 and the PWM was using timer counter 1. So what I have done is set up a spreadsheet with the different relationship between the output compare channels, the frequency that I want. We could do this kind of calculation in our code, but divide instructions and the like are quite costly. So if we were very, very code limited, we'd want to directly program this. Output compare register 1A. We now know we can set it to 77 to get a value of 10 milliseconds. And because we've hard coded this, let's take out the milliseconds and actually indicate that this is timer counter 0 and that it's a 10 millisecond timer. So let's call this from main. Let's test this quickly. So let's choose a particular port like port B2 and set that as an output. So setting port B2 as an output, and then we must implement a timer interrupt service routine. Compare vector A, and you can see that this timer used timer counter 0, and all we want to do is toggle the pin which we've set up. Okay, so let's run this now and see if we have a 10 millisecond timer. So starting the data visualizer as before using GPIO in pin mode, adding a graph, signal 1, start and stop, and so we're toggling, so that means that every time we enter and exit an interrupt we are setting and clearing, so it should be. So you can see every 10 milliseconds we are now entering the timer interrupt service routine. What we now want to do is trigger the ADC instead of in free running mode to start a sample on this timer interrupt. Let's have a look. So back to the data sheet, look for the ADC and the registers, and here we can see the trigger sources of the ADC and that there is actually a trigger source on timer counter 0 compare match A. So from status register B, we go to our ADC initialization routine and we change our trigger source to timer counter 0 compare match A, which means we set these 2 bits. And 0. So that means that we are now starting an ADC sample every time this timer triggers. So our ADC interrupt service routine can now change, and what we need is an accumulator to keep adding the values to, and then another variable for average. So let's create these variables at the start of our program. In general, when we use variables in an interrupt service routine, it's good to make them volatile. That means because sometimes the compiler can't see that they are being used in the program, so optimizes them out. So we're going to create volatile variables, and we're going to make this a UN32 because we're going to add up quite a number of samples and we might have some pretty large values. Okay, so now we have three variables, one to keep track of adding up all the ADC samples, one for average, and one for the number of samples. So in our ADC routine, we're going to use our accumulator and keep adding the value which we are getting in from our ADC, which is just duty, and then we're going to add samples. And now we want to do something. We want to calculate an average, but only if samples is 100. So if, remember equivalency is two equal signs. And now what we're going to do is an average is equal to accumulator divided by 100, and now we reset both the accumulator and the number of samples. Okay, let's set a breakpoint on average and see if we hit this and if we are now averaging every second. Okay, so we do hit this the first time, average is equal to 0, and we can see we've added up quite a number of samples, and we have 100 samples. Let's run again. Now we can see an average value, and if we start covering the light sensor, there's a bit of a lag, but then the next time it's high. So you can see we are now averaging every second. And in the next video, let's see how we can send these status updates using the UART which we set up before.